scatter plot, hopefully you're a couple steps ahead of me on the scatter plot. Here I'm going to start by writing down what each axis is. It's actually already labeled for us. Low temperature is on the x-axis. High temperature is on the y-axis. Something I'm going to do here in the middle is figure out what my scale is. Here, if this is 20, I have 1, 2, 3, 4, 5 boxes to get to 30. So that would be 22, 24, 26, 28. And if it's helpful for you to label those in between, you can absolutely do that. On our x-axis, we actually have the same thing going on. We're just starting kind of 50. So this would be 52, 54, 56, 58. There, so we are going up by 2s. This is a really common thing to see, and I don't think we talk about it a ton other places. But what is really an important thing to look at is this. This right here is not 0, 0. Right? That little break in the graph is something that you see like in the newspaper or in a lot of online articles, and it actually makes things a little bit misleading. Because it looks like it's 0, 0, but then you have that break there. So it's something to look at, because sometimes the scale of the graph can, like the editors or the people who are writing the article, will make the scale of the graph such that it looks like there's a relationship when maybe there's not. So it's a good thing to take a look at. All right, I'm going to plot these points now. So I'm going to go over to 26. And up to 49, you're going to have to do this on your quiz next Tuesday, and we'll do it a bunch of times in between now and then. So 26 is right on a line, but 49 is going to be right between 48 and 50. So 26, 49, right there. 28, 50. 30, 57. So 57 is going to be right between 58 and 56. 32, 54. 34, 60. So can we count 60. 35, 58. 2, 34, 35 is going to be right between these two, and then a little easier to do on your paper than it is to do up here on the smartboard. 37, 64, so 32, 34, 36, 37, right in between here, 64, 24, 38, 66, so 2, 4, 6, 41, 63, and 45, so 2, 4, 5, 72. All the way up there. So there's our scatter plot. Just a little practice plotting those points on that XY axis. So I kind of clicked off every one of those points that I graphed, and I'm going to go ahead and check off that I constructed that scatter plot. So the next thing it says is draw a line of best fit. All right, so when we're drawing a line of best fit, yesterday we did it a little bit. But today what we're going to do is be very specific about how we draw this line of best fit. First, I'm going to use a straight edge up here. You can use that little half sheet that we did. You can use your phone or your calculator as a straight edge. But what we want to do with this line of best fit, our job, is to get the same number of points on top as we have on bottom of the line. Okay? We want the line to kind of cut through our data so that it can be a good representation of our data. Again, this is not a connect the dots situation. So here's what my line of best fit is going to look like. Again, I have this straight edge, and before I let it go, I'm going to kind of play with it and see if 1, 2, 3, 4, 5. I have 5 dots below. 1, 2, 3, 4, 5. I have 5 dots above. Okay, if you feel like that's not the right slope, if you feel like you need to mess with it a little bit, you can, like, I don't know, maybe something like that. Okay. I feel like maybe I need to pull the bottom of this down a tiny bit. Do you agree? It does not need to go through 0, 0. And remember, this is not 0, 0. So even if my y-intercept looks like it's going through there, it is not. Okay. Your line of best fit is going to be a little bit different than mine in every case. There's no way we're going to all draw the same line. So from here on out, your work might be a little different than mine, but you can go ahead and kind of pick the same points I do just so you can be kind of with our work. So we drew a line of best fit. Calculate the slope of the line by picking off 2 points from your line of best fit. Okay, so we're going to use our line. Now the rest of our work is going to be about that line. Okay, so I'm going to pick 2 points. I have a nice point here. And I have a nice point, oh man, ooh, there is a nice point. Those are my 2 nice points. I don't know, the rest of them aren't really on. So this point here is 2450. And the other point that I have over here is, oh gosh, so 42, that's 44. And that's going to be 68. 44, 68. So now we're going to do slope with those 2 numbers. When I do this in 7th period, it's probably going to be a little different than this line was. Okay? And again, these are not points that were on our table at all. These are points from our line. So I'm going to subtract my y, 68 minus 50. And subtract my x's, 44 minus 24. All right, 68 minus 50 is 18. 44 minus 24 is 20. And I'm going to reduce that just so it's a little nicer to work with. 2 goes into both those. 2 goes into 18 9 times. 2 goes into 20 10 times. You do not have to reduce that. You don't want to. So my slope is 9 over 10. If you got a slope of 1, if you got a slope of 8 over 10 or something kind of this area, fine. It definitely should be positive, right? We have an uphill line, so we definitely should have a positive slope. Now, here is where we use that linear modeling situation that we dealt with in the last unit. Construct an equation in y equals mx plus b. So, y minus our y value, mx minus our x value. I'm going to use the slope that we found, which is 9/10. I'm going to use 2450 just because the first layer. So 24 is going to go by my x. X goes by x. 50 is going to go by y.
This is Erin.
Yes.
Okay.
The slope of 1 is
No problem. Bye.
All right, and then we're going to do a couple more steps. We need to distribute our 9/10. Oh, I'm not really interested in doing that on my head this morning. I don't know about you guys. Oh, there it is. Came up. So I'm doing 9/10 times 24. Get 21.6. Not so bad. I kind of expected that to be worse. So when we're working with point slope, you always, that order is important. We always want to distribute first and then bring over our 50. 50 minus 21.6. I think it's 28. Don't be freaked out about the fact that that doesn't really match our graph, because here's the thing. My y-intercept is coming down in this like break area. So, because it's in the middle of that break area, we're okay there. We're all right. If we had a nicer graph, if we had a nicer grid, and we could just calculate that, you could just find y on the graph. All right? Good so far? Questions so far? All right. Keep rolling. Use your line of best fit to estimate a high temperature for a day in April, given that the low temperature was 42 degrees. So here's the thing about the line of best fit. Now we can use that because our line of best fit is kind of our estimate, right, for this whole relationship. And so now we can use our line of best fit to base the rest of, like, what would happen if it was 42 degrees at the low temperature? What would happen if the high temperature was 70? So here, our first question was low temperature of 42 degrees. So if we go back to our graph and look at 42, we don't have any data points on 42. But we're going to go up and we're going to use our line. It's just above this line right here. And that was at, let's see, that was 68, so that's 66. So I would say that's like, on our line, it's just about 66.5. And illustrate on your graph just means put that point there and make it obvious to us. Use the equation of best fit, of the line of best fit, to estimate the high temperature. So if we're looking for 16 degrees, that's our high temperature. So our line was this guy here, 9/10 x plus 28.4. And high temperature, is that on your x-axis or your y-axis? Was high temperature x-axis or y-axis? Looking at that graph, it's y. So we would put 16 in for y and then solve. The other option is for you to put that into Desmos. Put that equation into Desmos and look for 16 in your y. Do you guys like using Desmos like that, kind of backwards better? Okay, so I will do that. So 9/10 x plus 28.4. And then if we pull up that table, we're looking for 16. So I need to go backwards because at -2 on my x, I'm at 26. So I'm going to go, I don't know, -10. I'm at 19. I'll try -15. I'm at 14, so I went too far. So I'm going to do -12. Not far enough. -13. So somewhere between -12 and -13. And that's fine. You can try, I don't know, -12.5 and see if we can get right on there. But between -12 and -13 is good for me. Yeah. You put 16 in as your x, though. You needed it as your y. Just flip them. All right, estimate the low temperature given the high temperature is 80 degrees. That we can do off of our graph. So I'm going to go back to the graph here. Again, high temperature is on our y-axis. So if I look out here at 80, let's see, here was 70. Oh, that's off my graph. 72, 74. So we're going to have to use our equation instead. again, our high temperature, we want 80 out here as your high temp. So what X's do you think we'll be looking at? What X should I try? 50? Okay. 50 at 73.4. What else should I try? What about 65? Oh, it's too much. So let's try 60. 82, a little too much. 58. Not 5. 58, 80.6. Pretty good. I'll take it. What do you think about this correlation, positive or negative, when you're looking at your scatter plot? Positive, absolutely. It's uphill, so it's positive. Is it weak or strong? If you're going to estimate an R value for this, are they close to a line? Yeah, absolutely. What we cannot say that the low temperature is causing the high temperature, right? That's not what's happening here. Weather is happening here. The seasons are happening here. Climate is happening here. But these two do have a strong positive correlation happening. All right, did we have one more question there? Or that was the last one. Cool. All right, a survey was done to determine if there was any connection between the price people pay for their expensive car and the current value of their house. So now we're talking about how much your car costs and how much your house costs, and whether those go together. All right? So a calculator was used to determine the line of best fit, and here's the equation. So for this data, we're not drawing the line and calculating the line. We're given the equation. So I want to look at this a little bit. Here's our y-intercept. And here's our slope, right? It's 12 over 1. And our slope here, our y's are on top. Our y is house value. There is a U in house. And our x is car cost. So what's happening here if we have 12 over 1 is that as our house value goes up, so does our car cost, right? But the house value is going up more. It's going up 12 times what the car value is going up. That's how that relationship of the slope works there. They're both going up together because this is positive. We have a positive slope, right? Use the line of best fit to predict the house value of a person whose most expensive car costs $19,500. Okay, so car cost is our X. So since this is a car value, we're going to use our equation and put this in for X. So here's how that looks. 12 times 19,500. You can also pull up the table in Desmos. You'd be putting that value in for X. Okay, 12 times, I'm going to clear out. 12 times 19,500 plus 33.76. Okay, so our house value that goes with this from our line is 267,766. Let's see if I can remember that. 200, no, see, you can't do it. 67. So that's using our line of best fit. Now, it says, is this prediction an overestimate or underestimate of the actual house value? We actually have a data point for this. the data point that goes with this is right here. So if you compare what our line gave us and that house value right there, is this over that value or under that value? Yeah, that's an over estimate. So if you want to envision the way this line would look in the scatter plot, the line would be an uphill line, and that actual data point that we're talking about would be over, above that line. Some of the others might be below, because that's how best fit lines work, okay? But this point would be above the line. The R value is determined to be 0.97. What's that tell us about the correlation? Is there a relationship? Is there a relationship? It's a positive number. It's close to 1, so this is a strong positive correlation. In context, what that means is as our car value or car cost goes up, house value goes up as well. But we said, and we've said since yesterday when we started this unit, we can never say that with a scatter plot that our x values are making our y values happen. So what else is going on here? What isn't on this graph, or what information are we not given that's actually making these things happen? What drives, what causes you to be able to buy a car and a house? What do you need?
Why would the price go up for both? Why would you be able to get an expensive car and an expensive house?
Job,
Yeah.
income, just money, however you're getting it, whether it's because, you're have a good job or your family has money, whatever's happening here, it's all driven by your income. So this is a really good problem. Hopefully it will help you link together that we can't say cause with these at all, because the OSC will try to distract you in April with that word cause. Okay? All right, last one for today. Ms. Musto opened a new coffee shop. She recorded the number of customers she served between opening and noon for the first 20 days of business, and her results are shown on the graph. Which line best fits the data? And then you're given a bunch of lines. Okay, so I can't really do this without drawing a line for myself. And so I'm going to draw a line for myself. Ish? Is that what your line looks like? So this is very similar to those weird little problems we did in the last unit. So here's what I'm going to look at first. I'm going to try to get rid of some options just based on the y-intercept. If we're looking at 10, 20, 30, and 20, which one of those seems like it would be really out of place? Is there one we can get rid of? 30, it seems like it might be a little high, but 30 actually I don't think is as ridiculous as 10 is. Do you think you could start a line of best fit at 10 and go through be a good one, a good fit for those dots? I don't think so. So I would get rid of that one just to start. That way you don't even have to think about that option anymore. And now what we have to figure out is our slope. I don't think 30 is terrible, but I definitely think 20 is better. So I would almost kind of highlight these two for myself. The thing you have to be really careful about now when we're working on slope is that we're not just going from here to here up 1 over 2, right? How many units are we going up between 20 and 30? 10. And how many units are we going over when we go over 2 boxes here? 5. So you have to pay really close attention to those units, and I feel like it's easier when you can draw on it, like I just did, than it's going to be on when you're looking at a screen from the OSD. So 10 over 5 reduces to 2. If we just counted, we go up 1 over 2 and think it was 1/2. Okay? Let's see if we can get a jump on tomorrow. Still.